Hey, I'm here with Dr. Anthony, one of the teachers at First Millennium. Dr. Anthony, explain to us Bohr's planetary model and the electron quantization and whatnot.
Okay. Prior to the Bohr model, the accepted model was one which depicted electrons as orbiting planets. The flaw with the planet-like model is that an electron moving in a circular path would be accelerating. And an accelerating electron creates a changing magnetic field. This changing magnetic field carries energy away from the electrons, eventually slowing it down enough so that the nucleus could capture the electrons. Bohr built his model upon spectroscopic observations of atoms. Spectroscopists observed that an atom can only absorb certain energies or colors called the absorption spectrum. And once excited, it can only release certain energies, which we call the emission spectrum. And these energies are the same. Bohr used these observations to argue that the energy of a bound electron is quantized. And he suggested that the planetary model could be saved if one new assumption was made. Certain special states of motion of the electron corresponding to different orbital radii would not result in radiation and could therefore persist indefinitely without the electron falling into the nucleus. In other words, electrons travel in stationary, stable orbit. This model allowed for the idea that electrons become excited and move to higher energy levels for brief periods of time.
What?
Bohr's theory says that the atom is like the solar system, where electrons travel on a fixed path. Electrons can jump to a more outer energy level when energy is added. When energy is taken away, the electron will jump to a lower energy level.